Okay, so I am now looking at number 26 on page 54. We're going to be talking about how to find the distance between 2 points on a coordinate plane. So what you're seeing right now is a coordinate plane. All it's missing is a couple of axes. So we want to drop our y-axis right there and our x-axis right there. Now, because of the numbers we're using, I slid the origin down a little. Remember, right there, our point 0, 0, still the origin. So the information the book gives us is that you have point C, 12, 6, and point D, negative 8, 18. So we have C, which is 12, 6, and point D, which is negative 8, 18. So again, you ultimately will be able to solve for the distance of these 2 points using only the equation. But given that we're just getting started, I want to make sure that you guys are able to visualize the problem, look at it, and see whether or not your answer makes sense. So let's go ahead and plot those 2 points. So 12, 6, we're going to go right 12 on the x-axis, up 6 on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Up 1, 2, 3, 4, 5. We're going to go right there. 12, 6. And then negative 8, 18. So we're going to head back left on the x-axis, up 18. 1, 2, 3, 4, 5, 6, 7, 8, and then up 18. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. And looks like we're going to run out of room right there. So that's our line segment right there. Now, if you look at the 2 lines, again, it's important to realize that the distance formula is a derivative of the Pythagorean theorem. So if we were to call this a right triangle, this A, this B, and this C, then we would easily be able to say that A squared plus B squared equals C squared. Because we're looking for the distance of the hypotenuse right there, we want to isolate C. So what we're going to do is we're going to take the square root of both sides, and that gives us C equals the square root of A squared plus B squared. Now, if you have the distance formula in front of you, which you should if you have your book, you'll see that those two are very similar. And so what we want to look for here is what exactly represents A and B. Now over here, notice that I put A on the y-axis. So I'm going to erase some stuff here, get a clearer look at it. And, oops. And I notice that this point right here, I'm just working with the y's now. Now notice I put the y-axis in red, so I'm going to mark all the y numbers in red too. So there I have, that's 18, and this is 6. So you know that the y components now are 18 and 6, so you should be able to see that this distance is 12. And we got that distance using what we've been doing with distance on a straight line from the beginning, just subtracting the 2 numbers and taking the absolute value of the difference. That was the definition of distance that we had. So if we have that our A equals the absolute value and of, let's say, y2 minus y1, then we get A equals 18 minus 6, or A equals 12. Let's plug that down back in here. So now A equals 12. We're going to do the same thing for our x's, and those are in green right now. So let me erase some stuff, clear it up a little bit. So know that that's side B right there. Now, on our x-axis, this is -8, and this is 12. So we do the exact same thing. We go 12 minus a -8. That's going to give us 12 plus 8, or 20. Now that's already positive, but if it wasn't, we'd still take the absolute value because distance is always positive. So we go 20 squared there. And that's going to give us the square root of 12 squared plus 20 squared. Now I'm going to stop for a second. I'm going to flip over to another page, and we're going to walk through this algebraically. So we've been really kind of using that graph as our crutch right now. And I want to show you how, using just the 2 points and the equation, that we end up in the same place. So whenever I do this, I like to start off by writing down what I have, what I know. I'm going to start off with my 2 points. My 2 points are -8, 18, and 12, 6. So any coordinate pairs that we have are split up x, y. So I want to make sure that when I do that, I differentiate between the 2 points. So I'm going to name this one x1, y1, so I'll call that point 1. And the 12, 6, I'm going to call it x2, y2. Now I know that I'm going to be needing the distance formula. Why? Because the question says, find the distance. And, well, we're talking about the distance formula of this section. So it makes sense. So I'm going to write that down. And I know that my distance is equal to the square root of x2 minus x1 squared. So the square of the difference of the x's plus the square of y2 minus y1, square difference of the y's. So look at that really carefully, because what I'm going to do is I'm going to flip back to the graph, and I want to highlight this equation right here. So you see that that's c equals a squared plus b squared. And then you look over at how we found a, how we found b, and you see that it's the exact same thing as over here, our distance formula. So this is something that you guys have been doing on and off for a couple of years. It's just never been called the distance formula. You're just asking to find the length of the hypotenuse. So now that we have our x1, y1, x2, y2, we have our equation. Now all we have to do is plug things in. So we go distance equals the square root of, we put that open parentheses there, we see that x2 is 12. We look over, see that x1 is -8, and we make sure we put our square right there. We then add in, we go y2. Look over there, we see that it's 6. And we subtract 18 again, and we square that. Again, keep in mind that because we're squaring them, the answer is going to be positive. It doesn't matter whether we go 8 minus a minus 8, or 12 minus a minus 8, or -8 minus 12. We're going to get the exact same answer. So that gives us 12 plus 8, which is 20 squared, plus 6 minus 18, which gives us -12 squared. Again, keeping in mind that -12 squared and 12 squared are the same thing, let's look back here at the graph, and hey, look at that. We got c, which is the length of the hypotenuse, that's the distance we're looking for, equaling the square root of 12 squared plus 20 squared. Look over here, doing it algebraically, 20 squared plus -12 squared. Same problem. So 20 squared is going to give us 400. -12 squared is going to give us 144. We're going to add those two together, and we're going to get the square root of 544. Now the book says to go ahead and point that out to, or put that out and estimate to 1 decimal point. So pull out the calculator and we get 23.3. Now again, technically, calling it the square root of 44 is more accurate, but the book's calling for estimation of 1 decimal point, so we give it to the estimation at 1 decimal point. Now over these past 3 videos, midpoint 1, midpoint 2, and now distance formula, I've covered everything you're going to need for this assignment. Keep in mind that on numbers 36, 38, 40, 42, and 44, you're finding both. You're finding both the midpoint and the distance. If you have remaining questions, before school, after school, at lunch, I'm always available, or go ahead and email me. Thank you very much, and I hope this made things easier for you.